An electrostatic field, often just called static electric field, is the electric field created around a static electric charge. The strength and direction of this field depend on the magnitude, sign, and distribution of charge creating it. A static electric field is conservative, meaning the work done by the field on a charged particle moving between 2 points is independent of the path taken. As a result, the potential energy in a static electric field is well defined. To simply put, an electrostatic electric field is a region around charged objects where electric forces can affect other nearby charged objects or particles. Charles Augustin de Coulomb was a French physicist who made significant contributions to the understanding of electrostatic electric fields. He formulated the Coulomb's law, which describes the force between two charged objects. Coulomb's law states that the force between 2-point charges is directly proportional to the product of their magnitudes and inversely proportional to the square of the distance between them. This foundation principle provides the basis for understanding how electrostatic electric fields behave and how they interact with charged particles. Coulomb's work laid the groundwork for further developments in electromagnetism and the study of electric fields. The Coulomb's law, in its equation form, is often expressed as F equals K times Q sub 1 times Q sub 2 divided by R squared. Applications of electrostatic electric fields include electrostatic printing. Electrostatic printing attracts and deposits toner particles onto paper, enabling the printer to produce images or documents. Static electricity in clothing. When different fabrics come into contact, such as inside a tumble dryer, an electrostatic charge can accumulate in your clothes, particularly those made of synthetic materials. Electrostatic precipitator. A precipitator is an electrically charged device that removes impurities from gases by applying energy selectively to particles, maintaining gas flow. For comparison and contrast, the electrostatic electric field originates from stationary electric charges. The field is generated by the presence of the static charges that create an electric force in the surrounding space. This field is purely due to the electric charges and does not involve any changes in magnetic fields. It is also used in applications where control of charge is required, such as in capacitors, electrostatic precipitators, and electrostatic painting. It's also described by Coulomb's law for electrostatics, both of which underscore the field's dependency solely on change configuration.
Induced electric field. This is the field arises from changes in the magnetic environment, particularly variations in magnetic flux. Meaning, this induced electric field can only be created in the magnetic field or in the flux in the magnetic field. Simply put, any instability in the magnetic field will create induced electric field. So any variations in the magnetic field will create electricity. Michael Faraday, an English scientist, discovered electromagnetic induction in 1831. Faraday conducted a series of experiments that demonstrated the induction of an electric current in a coil of wire when the magnetic field around it changed. He discovered that it was not the presence of a magnetic field that was essential for the generation of electric current, but rather the movement or change of the magnetic field. This means that it was not the magnetic field itself that made the electric current, but it was the movement of the magnetic field. As I said before, it was the instability or the changes in the magnetic field. Example of induced electric field is transformer. Transformers are devices used to increase or decrease the voltage of alternating current in power systems. This alternating current flows through the primary coil, creating a changing magnetic field. So in the second coil, This changing field creates the electricity, so meaning the alternating magnetic field creates the electricity in the second coil. Now, comparison and contrast. Induced electric field is very different from electrostatic electric field because electrostatic electric field originates from stationary electric charges, while induced electric field is created by changing magnetic fields. It can only be created through a magnetic flux through a region when there is a change in the magnetic field, while the electrostatic electric field can only be created by static charges in a surrounding field or in a surrounding space.